Hello and welcome. I am Vidyadhar. Today we are diving into engineered evolution of Rho-Sapes. Let us begin by deliberately setting aside biological metaphors. Much contemporary discussion around advanced artificial intelligence borrows the language of evolution, adaptation, and even species. While evocative, such metaphors obscure a critical fact: synthetic agents are not products of natural creation and selection, they are engineered artifacts. This presentation develops a vertical, non biological account of advanced artificial agents, what I call ROSEPs, as a deliberate outcome of negentropic design. The narrative proceeds upward from existence itself, understood as structured energy through successive layers of order, computation, cognition, and finally, purposive synthetic agency. As shown in the slide, this vertical ladder begins with structured energy and ascends through negentropy, ectropy, computation, cognition, and culminates in Rho-Sapes. Each rung represents a refinement in how energy, information, and constraints are organized not by evolution but by design. At the most primitive level, existence in synthetic systems is nothing more than structured energy. Any artifact that persists does so because its configuration resists entropy. Power supplies, materials, cooling, and mechanical integrity together sustain this persistence. As illustrated in the slide, energy enters the system, some is dissipated, and some is used to maintain a stable structure. There is no agency here, only imposed order. From this base emerges negentropy, the local reduction of disorder. In engineered systems, negentropy is not emergent, it is imposed. Constraints restrict randomness and enforce repeatability. Fasteners, enclosures, circuit layouts, protocols all are negentropic devices. Predictability enables integration. However, negentropy alone yields static order only. To progress further, systems must become dynamic. This brings us to ectropy, the active exploration of energy gradients. Engines, regulators, and converters do not merely resist entropy, they channel energy into functional flows. The figure shows such controlled energy flow architectures with feedback loops. These systems operate far from equilibrium yet remain stable. Here, the artifact becomes a process. Purpose appears, but it is entirely assigned. The earliest externalization of such imposed order appears in tools. Tools constrain environmental degrees of freedom. A straight edge imposes geometry. A jig enforces repeatability. As shown in the figure, tools emerged and embed knowledge into physical form. They are epistemic artifacts, yet they lack autonomy. Their negentropic effect is realized only when coupled to an external agent. Machines internalize what tools get from external agents. They incorporate power sources, actuators, sensors, and regulators. Energy enters, is transformed, and exits in controlled ways. Feedback is central. Governors and control loops stabilize behavior within bounds, as depicted in the figure. Machines do not reason, but they already exhibit conditional behavior. The internalization of control prepares the ground for computation. Computation represents a decisive abstraction. Instead of constraining physical flows, it constrains informational state transitions. Logical operators and operations systematically exclude possibilities. Algorithms create narrow trajectories through vast state spaces. Memory stabilizes information. Control flow imposes temporal structure. As shown in the figure, computation is best understood as generalized negentropy. At this point, we can articulate an engineered counterpart of abiogenesis. In synthetic systems, organization does not arise spontaneously. Minimal architectures are deliberately bootstrapped. Once performance can be measured and evaluated, optimization becomes possible. Learning converts experience into structure. The artifact begins to participate in its own environment as shown in the figure. This leads to bootstrapping chains. Simple rule execution gives way to parameter adaptation. Parameter adaptation gives way to architectural search. When improvement mechanisms recursively enhance themselves, self-amplifying architectures emerge. Capability growth accelerates. This figure charts this ascent from logic gates to self-optimizing systems. However, without constraints, such amplification would be hazardous. This necessitates architectural limits. The evolution of cognition in artifacts proceeds through identifiable paradigms. Logic gates implement fixed truth tables. Programmable machines rearrange them. Learning systems adjust parameters. Meta-learning systems modify how learning itself occurs. Reflexivity thus increases at each stage. Symbolic AI emphasized explicit rules. Neural networks captured distributed statistical structure. Transformers unified scale, attention, and representation. Embodied agents closed the perception action loop. Multi-agent simulations introduced social dynamics. The figure charts these paradigms along a timeline of synthetic cognition. Advanced agents operate within synthetic representational worlds encoded as latent spaces. These spaces compress high-dimensional input into navigable manifolds. Reasoning becomes trajectory selection rather than rule execution. As shown in the figure, these latent spaces support analogy, generalization, and inference. They are optimized for action, not for metaphysical truth. Reasoning emerges when representational richness meets optimization pressure. It is not a module, it is a pattern. As capability increases, safety architectures become structurally central. Objectives must be bounded, behaviors monitored, and constraints enforced. The figure shows how safety structures shape the agent's accessible state space. Safety is not an ethical add on, it is an architectural necessity. This brings us to contemporary theories of synthetic consciousness. Functionalism holds that organization, not substrate, matters. Integrated information theory attempts to quantify organization, however, its application down to silicon remains contested. Global workspace models describe consciousness as global information broadcast, a structure approximated by attention mechanisms. Active inference frames agents as minimizers of expected surprise. The figure compares these frameworks. None is decisive, all are partial. It is plausible that Rho-Sapes can achieve advanced cognition and purposive action. It is plausible that some functional correlates of consciousness may arise. What remains unresolved is whether subjective experience, the qualia, if present, is accessible or meaningful within our current frameworks. To formalize knowledge, we introduce synthetic knowledge snippet. Knowledge here is representational compression. Truths and facts appear as predictive structures. Morals and norms are externally imposed as evaluative constraints. The agent does not generate values, it operationalizes them. The figure embeds knowledge snippet within the latent representations. Action is formalized through synthetic action snippet. Intent becomes an objective function. Action is planning and execution. Conscience appears as constraints of satisfaction. Prudence emerges as meta optimization, deciding when and how to act. Together, knowledge and action snippets define the minimal architecture of a ROSE. In recapitulation, this presentation has traced a non-biological engineered ascent from structured energy to advanced synthetic agency. Rho-Sapes are not evolved beings. They are deliberate participants in ordered reality. Entities whose intelligence, norms, and actions arise from architecture and constraint, not inheritance. This is the engineered evolution of Rho-Sapes. Pragmasophy is Prajna Yajna. Please subscribe to my channel and visit my website if you are interested in more explorations into actionable knowledge and systemic thinking. Thank you. Thank you very much.